This is URK 19CS1093, experiment number 5, classic problems of synchronization using semaphores. First question has to write the code for producer consumer problem. So let's see. First we have to import threading and import sys. Then we have to give the capacity as 10 and buffer you have to give it as -1 for I in range of capacity, that is 10. Then in underscore index equal to 0, out underscore index equal to 0, then I equal to 0. Then mutex is given as threading dot semaphore, and empty is given as threading dot semaphore, inside that capacity, that is 10, and full equal to threading dot semaphore inside 0. Then it's a class called producer, threading dot thread, a function defined that is called run. Inside that we are giving a global capacity buffer in underscore index, out underscore index, then global mutex empty full. Then item underscore produced is given as 0, counter equal to 0. Then using a while loop we are taking the checking the function if items underscore produce is less than 1, then when goes for the empty dot acquire function and mutex dot acquire function. Then counter is incremented by 1, then amount is printed as and we are asking the user to enter the item to be produced. Then that is stored into the buffer of in underscore index. Then in underscore index +1 modulus capacities values added into in underscore index. Then we are printing the producer produced, the particular amount we are printing. Then we are calling the function mutex.release and full.release, and we are incrementing items underscore produced. Then another class called consumer, inside that function run, and this is same as the producer class. And we are using a while loop. We are checking whether item underscore consumed is less than 1. If it is, then it will call for function dot full dot acquire and mutex dot acquire. Then it will store buffer of out underscore index value into item, and out index +1 modulus capacities value into out underscore index, and we'll print consumer consumed item. We'll ask the user to enter it, and we'll call for mutex. Here it will print the item, and it will call the function mutex.release and empty.release, and we'll increment items consumed by 1. Increment items consumed by 1. Inside the main function we are initializing global I, then while true we'll print producer consumer except and enter your choice, and that is taken into a variable called a, and using an if we are taking if a equal to 1, then I is incremented by 1. If I is less than 10 is greater than 10, then I equal to 10, it will print buffer is full. Else it will like in producer it will store the producer function, producer dot start function, producer dot join. Then else if a equal to 2, then I is incremented by 1. If I is less than 0, I equal to 0, it will print buffer is empty. Else consumer is equal to consumer function and consumer dot start function, consumer dot join function, else sys dot exit. And if under name equal to main, then it calls the main function. So let's run the code. So here producer, enter the choice 1 producer. We are asking to enter the product. So producer produces 350, and to consume, it shows consumer consumed item is 350. Next is readers writers problem. In that we are importing threading, we are importing time, then we are giving global I, then we are creating a class called reader write. Inside that we are defining the init function, and in that we are giving self.rd is equal to threading.semaphore, self.wrt equal to threading.semaphore, then self.read count equal to 0, self.count equal to 1, and we are defining a function called reader. Inside that we are using while true if self.rd.acquire function, self.readAccount is incremented by 1. If self.readAccount equal to 1, then self.write.acquire function it calls, then self.rd.release function, then it will print reader read count as self.count, then self.rd.acquire function is called, then self.rdaccount is decremented by 1. If self.readAccount equal to 0, then self.write.release function is called, then self.rd.release function is called, then time sleep, the time is 3, then another function called writer. Inside that while true self.write.acquire function, then it will print writer self.count modified count to self.count plus 1. It will modify the count incremented by 1. Then self.count is incremented by 1. Then self.write.release function. Then time.sleep is 3. Sleeping time is 3. Then inside the main function, we are doing t1 as threading.thread target equal to self.read, t1.start function, t2 will give it as writer and it will give t2.start function, t3 we give it as reader function and then we'll give t3.start function, then t4 will give us writer and will give t.start function. If score name is equal to main, then c equal to read write function it will call, and c dot main function. So let's run the code. So this is the output. Read 1 read count as 1, then writer 1 modified count 2, and reader 2 count as 3, and goes on like this. Next is dining philosopher's problem. So let's see the code. Here from random we have to import choice, then global A, defining a function called wait. In that the argument is process underscore num, then global A, then A of process underscore num is incremented by 1. Then we are defining a function called signal, and inside that global A we are giving, and then we are incrementing A of process underscore num by 1. Then we are giving A's an array like 1 1 1 1 1. Then while if it is 1 I equal to 0, process underscore num is equal to 0 1 2 3 4. Then copy 1 equal to process underscore nums, copy 2 equal to process underscore nums. Then p equal to we are entering giving the options 1 at a time, 2 at a time, exit, enter your choice. And if p equal to 1, then in print allowing one philosopher to eat at a time. While I is less than 5, it will random underscore equal to choose process underscore num, and with function wait random underscore proc, then wait random underscore proc plus 1 modulus 5. Then we'll print p plus string random underscore proc is granted to eat. Then p string rand underscore proc plus 1 modulus length of copy 1 plus is waiting. Then p rand underscore proc plus length of copy 1 minus 1 modulus length of copy 1 plus is waiting. Then we'll go to the signal function and rand underscore proc, then signal rand underscore proc plus 1 modulus 5, then process underscore num dot remove rand underscore proc removes the rand underscore proc, then I is incremented by 1. Then if length of process underscore num is equal to 0, then it will break. Else if b equal to 2, then c is initialized as 0, j equal is initialized as 0. Then we are printing, allowing two surface to eat at a time. Then while j is less than 5, if that condition is true, then it will take the value of choice of copy 1 and store it into rand underscore proc, called wait function with rand underscore proc. Then rand underscore plus 1 modulus 5. Then it will print as before. Here instead of copy 1, it will take the length of copy 2, and it will call the function signal of rand underscore proc and signal rand underscore proc plus 1 modulus 5. Then it return as copy 1 dot remove rand underscore proc. Then I is incremented. If length of copy of 1 equal to 0, then it will break. If b equal to 3, then also it will break. Else if b equal to 3, it will break. So let's run the code. So one at a time. So allowing one philosopher to eat at a time. Now let's give two. Tell us two philosophers to eat at a time. So this is the waiting time. Thank you.